Okay, video 4, contrast coding. So I'm going to create two new contrasts just so that you can see what contrast coding is. And as you gather from Cohen and Cohen and what you'll gather from running some of these models with me in class, is that contrast coding is just is the generic or general classification for a variety of different codes. So contrast coding is the generic term in which effects coding falls under. It's a very specific type of coding. And what I want to show you is when you think of contrast coding in general, there are all sorts of comparisons that you can make. And contrast coding means that you are making direct a priori or a priori relevant, theoretically relevant comparisons. So one thing I want to do is I want to start out, I'm going to copy my pet variable over to pet C1 and pet C2, and I'm going to create some contrasts for pet C1. It's just creating some contrast codes for my main effect. I'm just going to talk about main effects. The interactions and everything that we've done so far applies equally to all of these codes, so we're not going to belabor those points. What I'm going to do is expand your understanding of all different types of codes. So here what we have is what are called Helmert contrasts, or really what they are, they're pooled mean comparisons, and they're in an ascending order. So you can see here I've got cat, dog, fish, pig, and for my first Helmert code I have dog and cat contrasted, and then second I have fish contrasted with dogs and cats. So you could imagine that there could be ascending treatments that you have where you are interested in assessing whether one treatment is better than the next, and that there are different subtypes that you keep expanding to. So you can see here it's dog versus cat, fish versus dog and cat, and then pig versus dog, cat, and fish. And then the next thing I'm going to do is I'm going to set up a different set of contrasts. Let me see if I can do this. I'm going to copy and paste. And I've already run these. So you can see here, whoops, I guess I don't have those. There we go. Okay, now I have these different contrasts, and might as well paste these in here so that everybody can see them. All of this will be will be available for you to download. So what I've done is I've created specific planned contrasts where I have usual versus unusual. That's my first, and so it's 0.5, 0.5 for cat and dog, and minus 0.5 and minus 0.5 for fish and pig. And then what I do is I am interested in the difference between cats and dogs, and then the difference between fish and pigs. So I do a pooled comparison between usual pets and unusual pets. I'm assuming fish and pigs are unusual. And then I'm doing, within group, I'm doing a comparison between cats and dogs, and which are my usual group, and then doing a comparison within my unusual group, which is fish versus pig. And what I want to show you in this is that first I ran a linear model with just a main effect with pet, but I'm using the specific contrast of pet C1, which is my Helmert codes. And this is a summary that I get. I get an intercept, and then I get a main effect for my three codes. Because remember, there are 4 pets, and this is the Helmert code. So I get the first contrast, second contrast, third contrast, and that's exactly what I'm getting. First, second, and third contrasts. And you'll notice that there's only one main effect that's significant, and that is between cats and dogs. And we're going to talk about interpreting these effects later. And then the second is my contrast, my planned comparisons. And you'll notice that I've got completely different results. The one coefficient is pretty much the same as the previous one, but then you'll see unusual versus usual, and then cat versus dog, and fish versus pig. and some of them are significant, and you'll notice that they're significant. The p-values are the same when I do cat versus dog. Right here, p-value is the same, but the coefficient is different. And they're different for many reasons, of which you're going to learn about in the next video. So contrast codes can be set up in a variety of ways, and you'll want to be cognizant of the fact that oftentimes they need to sum to 0. Not only do they need to sum to 0, but ideally if you get the sum of the cross products across all of these rows, that they will indeed sum to 0 as well. And if you have the sum of the cross products equal to 0, they tend to be orthogonal. And these types of contrast codes are oftentimes efficient. They're efficient predictors because, one, they produce blue, but then the second is that we can readily interpret what the effects are because they're all zero-centered. So, so stay tuned for the next video. We're going to talk about how to interpret and perhaps compute some of these effects.